So here we are in Maya on the top viewport. I'm first going to start off with going over the definition of points and vectors, and then we'll move on to doing some manipulation of vectors visually and in the script editor. So to start, we have some points here, and a point can be any position defined in a 2D or a 3D space. So here I created some points with the locators. And just for simplicity's sake, we're in the top viewport so we can just focus on a 2D space for the moment. So now I'm going to use a CV curve to represent a vector. So we'll start with snapping a CV curve to world 0, connecting it to the first point A. So we'll call this vector A. And a vector has the definition of a vector, it has a start point and an end point. And this vector also has a length because of that start and end point. And because it starts at 0 and ends at A, it also has a direction. It is going from the start to the end in this direction. So now I'm going to draw a few more vector representations. So now that we have the vectors A, B, and C, what are we going to do with them? So I'm going to start by visualizing what it would look like if we were to add the vector A to vector B. So I'm going to duplicate vector A so that we can keep vector A here, but I'm going to move a representation of vector A and snap it onto B. Now what I've done here is I've taken vector A from its start and snapped its start point to the end of B's endpoint. So if we were to walk from the start of B's vector to the end of B's vector, then from the end of A's vector, or the beginning of A's vector to the end of A's vector, we get this point right here. And this is what we would call adding A to B. And this would eventually give us this vector after adding the two together. This line here is simply to visualize why we're getting this vector here after we add A and B together. So we'll call this point D. So what if we wanted to do this, but we wanted to actually add vector A to B in script? Well, that's very simple. We'll start with defining A to be a vector, and right now I'm going to do this just showing you the math behind it. So for A, I'll make a list and say that AX is -5 and AZ is -6. So if you look over here, we have X and Z for the position of point A. And then point B, look at that, and it has, the translate X is 4, and the translate Z is -5. So if we wanted to get point D, that we already have in the viewport, it's very simple. What that would look like is D would be defined by taking AX, so the first index in the A's list, plus BX. I'll put actually over here, don't know why I put that tuple mark, but put a comma, and then go A1, so that'll be AZ, plus BZ. Now, just notice I'm skipping Y because the Y-axis isn't actually doing anything on 2D viewport. So now that I didn't define A and B, so now I'll enter those two in. and that gives us d. So negative 1 on x and negative 11 on z. So I'll select the point that we found by moving this spline that represented the vector onto b. If I select this point, you can see that it also says translate x as negative 1 and translate z as negative 11. So since I'm snapping all these points onto grids, it makes it very easy to see how this is exact. So now that we've added a vector, what would it look like if we were to subtract a vector? So basically, if you subtract a vector, it's as if you were to take A, but go in the opposite direction. And C is almost in the opposite direction of A, but it's still slightly off. So if I were to take A and move it over to B, except instead of moving the start position to B, I want to move the end position to B. So I'm going to go insert and move my pivot to the other side, and then snap that to B. That would now give us this new point here, which is the exact opposite of what D is right now, because D was added to B. So I'll say that this is E. And this point would now represent this vector from world 0 to point E. Now how would we get that if we were doing the math? It's very simple, just like what you did with D. We had to say E, and I'll copy the same thing that we did before. So I say AX. In this case, I'm subtracting A from B. So I'd say B minus BX minus AX, and then BX, or Z, minus AZ. Now the order that we do this is very important. And the reason for that is if I subtract A from B, I end up at this point. If I subtract B from A, move this out of the way, I would end at this point over here. In this case, because of these vectors all being at world 0, addition doesn't give us different results. A, if moved to be at the end of B, gives us D. And then if we were to take B and move its end to the beginning of A, we also get D. So, now what if we wanted to use multiplication on a vector? Now, what multiplication can do is it allows us to scale vectors. So when we subtracted A from B and got our vector of E, one of the interesting things about it is it gave us the length of the vector between A and B. So one of the interesting things that we can do with that is we could find the exact middle position between A and B by using multiplication. So now what I'll do is I'll take E, we'll create a new vector called F, and I will say EX times 0.5, then EZ also times 0.5. And that'll give us a new point. And this point's going to be at 4.5 on X and 0.5 on Z. And you can see right here between the world 0 and E, we have this midpoint between this vector. So that's not the point between A and B yet. But what we can do, I'll quickly name this as well, so say this is F. So when we're referring to this vector here, I'm going to add F onto A. And if you think about that, I have this length of this vector. And if I were to just simply add the beginning of that to A, I would end up right smack dab in the middle between A and B. So now we'll take G, and say AX plus FX, and AZ plus FZ. And give us this new position right here. And if I were to, I need to print out the results. So that's negative 0.5 on X. And then it's negative 5.5 on Z. So if we name that, we can see that we've got this G vector right here, smack dab between A and B. And continuing on with talking about scale, if I wanted to even lengthen a vector, not just make it shorter, because it's a scalar, I can do things like multiply it by 2, or I can even multiply G by negative 2 to get the opposite direction, and even more and double the opposite direction. Let's take G, go H equals G X times negative 2, then G Z times negative 2. Which give us this point here. So H is now at 1x and 11z. So G in the exact opposite direction, but scaled by negative 2 would give us this point here, which is simply the length of G twice the length of G. Which brings us to the next thing we can do with a vector. What if we want to find the length of, we'll name this one as well. What if we wanted to find the length of H? Well, to do that, do a few things. So first, what we need to do is, some smart person figured out that if you take a vector and you square the x, then you square the y, and then square the z, and add all those together, it gives you the length of that vector squared. So first we want to get the h squared. So we'll take h x times h x and then I will add h z times h z. And that just gives us one number, which is the length of this vector squared. So that still doesn't tell us the length, but what we need to do is get the square root of 122. So just for simplicity, since Python has this lovely math module, I'm going to import math, then go math.square root on h squared, and that gives me the length of this vector here, which is about 11 units. So that brings us to the conclusion of this segment.